Have you ever stopped to think about how we build our homes? I mean, really think about it? Pretty much everything in our lives has been completely reinvented, but for the most part, we still build houses like we did 100 years ago. Well, that's all about to change. We are standing right on the edge of a massive revolution in construction. We're talking robots, we're talking factories, and a total rethinking of what a home can even be. And this isn't just about cool new gadgets. This is about solving some of the biggest problems we face today.
So let's be real for a second. If you've ever built a home, or even just watched one go up, you've probably asked yourself this exact question. Why does it take forever, and why does it cost an absolute fortune? You're definitely not alone in wondering that. It's a process that's just full of delays, weather issues, and budgets that seem to spiral out of control. And that's not just a minor headache, it's a deep, fundamental flaw in the whole system.
And beyond all the time and money, there's this enormous hidden cost, just mountains and mountains of waste. A landfill study recently found something that's honestly pretty shocking. 58% of the materials getting dumped in our landfills, we're talking perfectly good wood, metal, drywall, could have been diverted. That means more than half of it didn't need to be there at all. Every single home built the old way is just adding to this problem, and it's a problem we just can't afford to keep ignoring.
So how do we start to fix this mess? Well, here's our roadmap for today. We're going to start with the old way of doing things. Then we'll see what happens when you move construction into a factory. After that, things get really interesting with the rise of the robots. Then we'll talk about building for the planet, and finally, we'll pull it all together and look at the future of the home.
All right, first up, the old way of building. Before we can really get into all the cool new stuff, we have to understand what we're trying to improve on. And that means taking a hard look at traditional stick-built construction.
You've seen this a million times. It's called stick-built, and they mean that literally. A truck shows up, dumps a huge pile of lumber, the sticks, onto a plot of land, and a crew starts putting a house together piece by piece, right there in the mud and the rain and the wind. It's a craft for sure, but man, is it an inefficient and unpredictable way to do things?
And this is where the trouble really starts. I mean, think about it. You're completely at the mercy of the weather. A week of rain can turn your site into a swamp. A snowstorm can shut down work for weeks. Plus, the quality of the final house can be totally different depending on who's on the crew that day. And because everything is cut and fit by hand, labor costs go through the roof, and you end up with a huge pile of wasted material, offcuts and scraps that just get thrown away.
So, Section 2, Building in a Factory. If the big problem is the messy, unpredictable job site, what's the most logical solution? Well, you take the building process and you move it indoors, into a controlled factory environment. This was the first huge leap forward.
Now, this factory approach usually comes in two main flavors, modular and panelized. With modular, you're building entire 3D sections of the house in the factory. We're talking whole rooms, complete with windows, wiring, plumbing, everything. Think of them like giant, high-tech Lego blocks that get snapped together on site. Panelized is a little different. You're building the flat parts, the walls, the floors, the roof, in the factory. Then you ship those panels to the site and assemble them. It's kind of like a super advanced, precision-engineered kit of parts for a house.
And this is where you can really see the benefits. Just look at this comparison. A stick-built home can easily take a year or more. But with factory methods, you're working on the foundation at the same time the house is being built in the factory, which cuts the timeline way down. Costs are way more predictable, and waste, it gets slashed because computers are planning every single cut to be as efficient as possible. And while nothing beats stick-built for 100% custom designs, you'd be amazed at how flexible and beautiful modern factory-built homes can be.
Now, we've got to clear something up because it's a huge misconception. When people hear factory-built, they often think of old-school mobile homes. But that's just not what we're talking about anymore. As this quote says, modern modular homes are a whole different animal. They're permanently bolted to a foundation, they have to meet the exact same tough building codes, and honestly, they're often built even stronger because they have to be sturdy enough to be trunked down a highway.
Section 3, the rise of the robots. Okay, so moving into a factory was a game changer. It solved the environment problem. But what if we could also revolutionize the builders themselves? The next leap forward isn't just about where we build, but who, or maybe what, is doing the building.
Yep, welcome to the world of automated construction. We are talking about giant 3D printers that squeeze out concrete walls, robotic arms that can lay thousands of bricks with perfect precision, the whole shebang. And the goal is pretty simple, but it's totally revolutionary. Build faster,
build cheaper, and build with a level of quality that's almost impossible for a human to match every single time.
So how in the world do you 3D print a house? It's actually pretty wild. It all starts with the digital model on a computer. Then, a crew prepares a normal foundation on the site. And then the magic happens. A huge robotic printer on a rail system starts moving back and forth, squeezing out a special concrete mix layer by layer, building the walls right up from the ground. Once that's done, human crews come in to do the finishing touches, the roof, windows, and all the interior stuff.
The real jaw-dropper here is this speed. 24 hours. Let that sink in for a second. That's how long it took a company called Apis Core to print the main structure of a house. Just one day. I mean, think about what that means. A natural disaster hits a region. Instead of waiting months for temporary housing, you could literally print emergency shelters in a matter of days. This is a complete paradigm shift. And this isn't just some experiment happening in a lab somewhere. This is real, and it's happening right now. In Austin, Texas, a company called Icon is building entire neighborhoods of 3D printed homes. And they're working with nonprofits to provide beautiful, resilient housing for people who have experienced chronic homelessness. This tech is already changing lives.
And hey, automation is way more than just 3D printing. We've got robotic bricklayers that can place 3,000 bricks in a single day. That's way more than any human mason. We have automated welders that create perfect seams every time, making buildings safer and stronger. And inside factories, huge robotic arms can lift and place entire wall sections with pinpoint accuracy. Every part of the process is getting faster, safer, and better.
Section 4. Building for the planet. So we've figured out how to build faster and with incredible precision. But here's the billion-dollar question. Can we build better? Not just for us, but for the planet. Well, it turns out that all these innovations are also the key to tackling construction's massive environmental problem.
The whole philosophy is shifting towards what's called a circular economy, and this pyramid shows it perfectly. See, the old way was linear. You take resources, you make something, and then you throw it away. The new way is a loop. The top priority is to reduce the materials you use in the first place. Then, you reuse everything you possibly can. Recycling is actually only the third best option. The ultimate goal is to design waste out of the system from the very beginning.
And you might be thinking, that sounds nice, but is it really possible? Well, check this out. 94%. That's the waste diversion rate a company in British Columbia achieved. Instead of just bulldozing 3 old homes, they carefully deconstructed them piece by piece, saving everything they could. An incredible 94% of those houses was either reused or recycled. It can be done.
Now, sustainability also means using way less energy. And the absolute gold standard for that is something called passive house, or passive house. Now, this isn't about just slapping some solar panels on the roof. This is a fabric-first approach. It's about building a house that's so incredibly well-insulated and airtight that it basically acts like a thermos. It barely needs any heating or cooling at all.
And the results are just staggering. A certified passive house can use up to 90% less energy for heating and cooling than a typical new building. No, that's not a typo, a 90% reduction. Just imagine if your power bill was only a tenth of what it is now. That's the kind of impact we're talking about, both for your wallet and for the planet. But what's it actually like to live in one of these homes? It's a total game changer. The temperature inside is always comfortable, no cold spots, no drafts. You're breathing fresh, filtered air 24/7. It's also dead quiet inside because of all the insulation. And get this, if the power goes out in a winter storm, the house stays warm and comfortable for days, not hours. It's just a healthier, more comfortable, and safer way to live. And just in case you're picturing some kind of weird, futuristic box, think again. These homes are absolutely beautiful. The principles of passive house design, quality, comfort, simplicity, can be applied to any style of architecture you can imagine. It's proof that you don't have to choose between great design and sustainability.
Okay, we've covered a ton of ground, from the problems of the past to some truly incredible solutions that exist today. So let's bring it all home and look at what the future holds, both the amazing promise and the real-world challenges we still need to overcome.
On one hand, the promise is just immense. We're talking better homes, built faster, for less money, and with a tiny environmental footprint. But, it's not all smooth sailing. Our building codes were written for hammers and nails, not for 3D printers. The cost to set up a robotic factory is huge. We need to retrain our workforce for these new, more technical jobs.
And maybe the biggest hurdle of all is just getting people to trust that these new ways of building are not just different, but actually better.
So what's just over the horizon? Well, the pace of innovation is only speeding up. Imagine an AI that can design the most efficient building possible before anyone even picks up a tool. Picture construction sites run entirely by swarms of coordinated robots. We're even developing materials like concrete that can heal its own cracks. And all of this tech is leading to a future of mass customization, where we can build affordable homes that are perfectly designed for the people who live in them.
And at the end of the day, this is why all of this is so important. This isn't just about cool technology for the sake of it. It's about solving one of the most urgent crises we face, the desperate shortage of affordable, quality housing. In cities all over the world, people are struggling. Building faster, smarter, and more sustainably, well, it isn't just a nice idea anymore. It's an absolute necessity.
So where does that leave us? The big question is, will all this innovation finally deliver that better, more affordable, and sustainable future we all want? We have the tools. We have the technology. The stuff we've talked about today isn't science fiction anymore. It's here. The challenge is no longer about invention. It's about implementation. The home of the future won't be built with just sticks and nails. It's going to be built with data, with robots, and with a whole new sense of responsibility. The foundation is laid. Now it's up to all of us to build on it.